In this video, we'll be looking at some examples of perfect square trinomials. Now, these are the trinomials that you can essentially factor by seeing if they fit this pattern and then easily then determine that the factored form would be a plus b squared. So the strategies that you've already successfully used to factor these types of trinomials are not wrong, and you can still continue to use them. We're just looking at this because it's an additional strategy for your toolkit that also is more efficient, if it fits the pattern, that is. So there's a couple things we have to check to verify that the trinomial is a perfect square. The first thing we need to ask ourselves is, are the first and last terms perfect squares? So let's have a look at that. We have x squared, and we also have 9. So in this case, we know that they're both perfect squares because if you take the square root of each of those terms, you will either get you get a variable with no fractional exponent, which is what we want, and you also get a whole number. So we know that 9 is 3 squared. So we have proven the first and last terms are perfect squares. So that's one step down that gives us some kind of proof that this is a perfect square trinomial. The second thing we have to look at is the middle term equal to 2 times the square root of c times the square root of ax squared. Now, remembering that this is the general format of quadratic expressions, specifically trinomials. So that means that the ax squared term is just going to be x squared, and the c term is just going to be 9, and then the bx term, that's the middle term. So we're trying to see if it fits the pattern. Would it be equal to 2 times a times b? Like, would it be equal to 2 times the square root of this times the square root of this? That's what we also have to look for to prove whether or not it's a perfect square trinomial. So in this case, this is like the square root of ax squared, and then this would be the square root of c. So I'm just making that really clear so that we know that it lines up with this second condition that we have to meet. So the middle term, we're going to see if it's actually equal to this. So 2 times the square root of c is going to be 3. And then the square root of ax squared, that's x. So 2 times 3 times x, that will be 6 times x, which is 6x. And then is the middle term equal to that? Well, we have 6x, yep. So just from there, we've determined now that this is a perfect square trinomial. So both of those conditions have been met. And then now we can factor it. So since we've proven, I'm going to rewrite it here, x squared plus 6x plus 9, we've proven that it fits this pattern. So this is like your a squared, this is your 2 times a times b, and this is your b squared. So it fits the pattern perfectly to be a perfect square trinomial, which means that's like your a squared, that's the b squared, and that's the 2ab. So now we want to figure out what's actually the value of a, kind of like we did with the difference of squares. So in this case, a is going to be square root of a squared, which would be square root of x squared equals x. And then the b term, that's the square root of b squared, which is the square root of 9, which is 3. So now that we have this, x squared plus 6x plus 9, we've proven that it fits this pattern. We've figured out the a and the b value. So therefore, factoring this is as simple as rewriting the expression as x plus 3 squared. And that's the answer. So again, in terms of how much work would actually be required of you, you would only have to know that, like, you would only have to be able to identify and pick out what's the A value and what's the B value, and then kind of verify that it like fits this pattern if I were asking you to factor it. If you were being asked to only factor, then essentially this is really all you have to do. You would just have to give me this general pattern in that formula, and then substitute in the numbers to get it to this factored version. That would be it. If you were asked to verify that it's a perfect square and then factor it, then you would have to do these steps and actually prove that the first and last terms are perfect squares and the middle term is equal to this. So this is like the stuff in red, this is like our verification. The stuff that's in black, this is the actual factoring. So keep that in mind for whatever you're asked to do in a particular question, if you need to do the extra steps or not.